Hello, my name's Ian Spencer, and what we're going to look at today is an emulator for the Honeywell H mini computer. This computer was built around 1968 and used in many industrial installations. We don't have the real 112 running here, but we have an emulation on a PC, and I want to demonstrate to you how it works, how the control panel works, and how we can run programs on this quite antique computer. So let's start the emulation. What you can see on the screen, in the middle of the screen, is a representation of the 112 control panel, just like it looks on the real 112, with the 12 bits for the registers. And we can select the registers, register A, register P, register W, just as we would on the real 112. And if we enter some data into a register, we can clear the data from the register with a clear button, or we can clear all the registers by pressing the master clear button at the end of the control panel. But of course, entering things into registers is not what we really want to do. We want to run programs on the H112, and to do that, at the bottom right of the screen we have an electronic cassette, a simulated cassette drive, which will allow us to load programs into the computer. And also at the bottom there's a keyboard where we can input keys into the computer, and at the top of the screen there's a display which can either work as a digital group digital display, a typical display used on computers in the home around 1975-1976, or it can work in a teletype mode, which means it works like a Creed 7 ERP telex machine or a teletype ASR33, in that what we output to the screen will be scrolled. But first we need to load those programs into the computer. So we go to the cassette at the bottom, and electronically I will enter a cassette, which I call Demo 1. And this machine has what's called a hardware loader. So if I press the load button, and then the start button, loaded, then you hear by the word loaded that it's loaded those programs into the H112. Now we clear all the registers, and if I set the program counter to 0, we will run a program starting at location 0. So we go into run mode, and when I press the start button, the program begins running and displays ASCII lines of 64 characters on the screen. And because we're in display mode, we can actually position anywhere on the screen we want, and we can write text to the screen, and when we get to the bottom we simply clear the screen and start again, as we're doing with this simple program. Now I'm going to stop that program, clear all the registers again, and I'm now going to enter 200 octal into the program counter. That's bit 8. And the program located there will now run. So we set it to run and start, and you'll see that only a couple of bits at the end are changing here in the program counter, and that means that it's a very, very small program indeed. It's just a program to input something from the keyboard and output it to the display. So I'm going to enter some data. Oops. And you see what I've typed at the bottom is appearing on the display at the top of the screen. Now I stop the program, clear the registers, and I go to 400 octal. So in the program counter I set bit 9, which is 400 octal. I say run the program, and when I press the start button this program will start to run, and it says we're in teletype mode, and it's outputting rows of ASCII characters to the screen, and it's scrolling up the screen just the way a teletype would scroll, except that we can't read what's gone off the screen because we don't have any real paper. And the last program I want to demonstrate, so we'll stop this one, is a small program located at location 7200 near the top of the first 4K of the machine. And we put that in the program counter and we say run, and it says we're in teletype mode, and it puts an asterisk at the top of the screen. And I can now enter commands into the keyboard which will be accepted by this program. So I can say access 7200, and it prints out 7200 0022, meaning 22 is what's in location 7200. And if I hit the carriage return, it looks at the next location, 7201, and I can look at each individual location, and I can change the contents if I want. Now I'm going to stop that, and I'm now going to give a new command, dump 7200, 7300. So dump 100 octal characters to the screen. And you can now see that it's dumping in rows of 8 100 octal locations onto the screen. And that's the end of this small demonstration.